Controversy surrounding the first exomoon outside the solar system. The discovery of the first exomoon by a research team from Columbia University has sparked skepticism among some other astronomers. Astronomers have long known that finding moons around planets outside the solar system would be a significant achievement. However, a recent debate in the field of planetary science highlights just how challenging the detection of exomoons can be, according to Live Science. The story began in 2018 when a research team, including David Kipping, an assistant professor of astronomy at Columbia University, believed they had detected the first exomoon. This object orbits the exoplanet Kepler 1625b, a Jupiter-like world located about 8,000 light-years from Earth. The object was initially discovered through observations by the Kepler Space Telescope. Upon discovery, the moon of Kepler 1625b was named Kepler 1625bi. Later, it was further confirmed using data from the Hubble Space Telescope. In 2022, another research group, which also included Kipping, seemingly found a second exomoon, this time using only the Kepler telescope. This object orbits Kepler 1708b, a gas giant planet located 5,400 light-years from Earth, with a mass 4.6 times that of Jupiter. The potential second exomoon was similarly named Kepler 1708bi. The technique used to detect these exomoons is similar to the transit method, which has added over 5,000 exoplanets to the catalogue of planets outside the solar system. The transit method involves detecting slight dips in the light emitted by a host star, caused when a planet passes in front of the star from our viewpoint on Earth. The same principle applies to exomoons, though on a much smaller scale. If these moons are in the right position around their host planet when it transits the star, they too can cause a slight dimming of light. However, this slight dimming is the key evidence supporting the existence of Kepler 1625bi and Kepler 1708bi for the proponents of exomoons. Yet, the dimming caused by an exomoon is so subtle that it cannot be observed directly. Instead, researchers must rely on powerful computer algorithms to extract this information from telescope data. According to Kipping, both his team and the opposing group led by René Heller used the same data from the same telescopes, but the disappearance of Kepler 1625bi and Kepler 1708bi may be due to differences in how each team processed the data using algorithms. Kipping suggests that they might have missed Kepler 1708bi because of the software they chose to analyze data from the Hubble and Kepler telescopes. While this might relate to the software used by Kipping's team, Heller's group's software was slightly different. Kipping also proposed that Heller's team use their software because it is generally very reliable outside of its default settings and sensitive to certain steps used in data processing. This could explain why these exomoons were missed during calculations. Regarding Kepler 1625bi, Heller and his colleagues suggested using the stellar limb darkening effect, which means the edge of a star is darker than its center, affecting the exomoon signal. Heller's team believes this effect better explains the observations of the host star rather than the dimming caused by an exomoon. Kipping argues that this approach is not suitable for the potential exomoon because his team had already considered the stellar limb darkening effect when describing the existence of Kepler 1625bi. Heller and his team do not believe that Kepler 1625bi and Kepler 1708bi exist. At the very least, both Heller and Kipping agree that further research is needed. The reason these exomoons have appeared using the transit method is that they are massive, roughly the size of mini-Neptunes, with diameters 1.6 to 4 times that of Earth. If they do exist, they are enormous. Kipping thinks this is part of the reason why they are so unusual, that they are difficult to accept as the first exomoon discoveries. He plans to use the James Webb Space Telescope, JWST, to search for more exomoons that resemble moons in the solar system.